In this video, we're doing an example of the extreme value theorem, and we are looking on a continuous function on the interval from 0 to 3. Since it's a closed interval, we're guaranteed to have an absolute max and an absolute min, or global max and global min, and they'll either occur at a critical point or at one of the endpoints. So the first thing we do is identify any critical points by finding our h prime of x. Well, this is going to be a product rule. So first I'm going to leave the x alone and take the derivative of e to the negative x. So e to the negative x times the derivative of the exponent is negative 1. Plus, now I'm going to leave e to the negative x alone times the derivative of the other side, which is x. Now anytime you have this, the easiest thing to do is going to be to factor out any like terms, particularly the e to the minus x. And then see what we have left. So we're going to have a negative x plus 1. To find any critical points, we're going to set this equal to 0. And this part will never be 0. E to the negative x will never be 0. So that means our critical point is going to be where negative x plus 1 equals 0, which is at x equals 1. And we don't need to do a sign chart for that. Once we have our critical point, we evaluate our function at our endpoints and at our critical point and see what's the biggest and what's the smallest. So h of 0 is 0 times e to the negative x. It's actually pretty simple. It's just 0. H of 3 is 3 times e to the negative 3, or 3 over e cubed. It's going to be a pretty small number because of e being cubed. H of 1 is 1 times e to the negative 1, or 1 over e. Clearly the smallest is 0. So that's going to be our absolute or global, depending on which term you're using, min. They're synonymous. Now we need to know which one of these is larger. Well, one way of checking without having to find the decimal, if I multiplied this by 3 over 3, I still get the same value. And so I have 3 over 3e. E cubed is much larger than 3e. So that tells me that 3 over e cubed is going to be smaller than 3 over 3e, which is equal to 1 over e. So that makes the 1 over e our absolute or global max. When we have one of each, we are guaranteed it because of the closed interval and the continuous function by the extreme value theorem.